Okay, so let's go ahead and get started. Are you seeing me on video?
Yes.
Okay. All right. Hi, welcome to this session. So I'm Steve Olding and partner is Beth Huffer. We're from the ESDIS Standards Coordination Office, ESCO. So ESDIS, as you probably know, is the Earth Science Data and Information System. And the role of ESCO is to coordinate standards for use in NASA's Earth Science data systems. So, bit techie, standardsy stuff. But for a long-term archive, it's very important that we apply consistent standards so that people can use our data across the various generations of data that have been generated, and that those data are interoperable with other data. So our role is to really appraise standards that are coming in and help determine which of those standards should be used for NASA Earth science data. One of the joys of standards, they always say, is, one of the nice things about standards is there are so many to choose from. So that's part of the problem that we're trying to resolve, from the many different standards, which are the ones that are most applicable and best for use in Earth science data systems. Sorry we couldn't be with you this week. Beth and I were planning to be there, but some things happened and we have to participate remotely. So we'll try and do the best that we can with this. We were hoping this was going to be a bit more of a discussion session. I know a lot of the people that we were also hoping were going to be in the room were not able to travel this week. So we'll kind of do the best we can. Beth's got a number of things we want to go through, but hopefully we'll have some time, and we're very happy to take questions from folks in the room or online about any of the things we cover. So that said, let me hand over to Beth. Beth, perhaps you can tell us what you're going to go through today.
Yeah, thanks, Steve.
Hey, Beth, I think you're muted, just so you know.
Thank you. I was being brilliant, just so you all know. And okay, so the table of contents or the agenda for today is to just review what standards ESDIS has adopted or recommended over the past year. It's going to be a fairly high level overview, but we'll talk a little bit about each one and kind of let you know what's in there and what the objective is if we can. We also want to talk about data processing levels. We had a session last year that was quite lively and lots of people in the room, and we had a big discussion about data processing levels, and everyone agreed that the current definitions that NASA is using for data processing levels are confusing. They've been proliferating. We need to do something about them. Steve and I vowed to spend the next year, which was this last year, doing something about them. I have to confess, we didn't get as far as we had hoped, but we have written some new definitions, and we want to talk a little bit about those and maybe some other approaches to the way things have been handled in the past with data processing levels for NASA data. And then finally, we want to hopefully have a discussion, if we can do that in this virtual hybrid environment with you guys, about what ESCO can do to help the community in adopting these new standards. We recognize that the standards come out, sometimes they go up on our website and maybe people don't even know that they're there. And so, even when they do know, we recognize that it's not always easy. So we want to know if ESCO, if there's something ESCO can do, what would be helpful? What do data producers need? What do developers need? What do DACs need? And maybe we can generate a little conversation around that. We'll do our best. All right. So this last year, I think Steve listed out some of the standards that we have um, reviewed. So just to share a little bit about how that process works, usually somebody comes to us with a proposal or a request for comments on some proposed standard. And then the ESCO team works with that proposer to send out to facilitate a community-wide review of the proposal. And we get back comments, and then the proposer has an opportunity to respond to the comments. In some cases, it requires a second round review if there are really substantive concerns raised in the first round review. And once those reviews are all done, a recommendation, as the ESCO office writes a recommendation to ESDIS and says, hey, this went through a review, the community is mostly on board. We recommend this be adopted as a standard. A standard is kind of the highest level. Other things get adopted as conventions, which are not quite as rigorous as standards. And some things, I don't know, hardly ever do we not have anything get recommended. If we don't think it's ready for prime time as a standard, we'll recommend it as maybe a convention or even some kind of community, limited community convention. But that's how the process works. And we have been fairly busy this last year and have adopted several things or approved several things as standards or guidelines. The first thing I want to talk about is the Data Product Developers Guide. This is version 2 of that document, so it's been around for a little while. But the new version has just come out and is really going to provide high-level guidance for data producers in the earth science community that want to publish that data at NASA. So this document provides recommendations for how to design and develop a data product that will be accurate and of high quality and usable by the community out there. And I just want to touch on a few things high level that are in here. We've got recommended formats. We've got some discussion about what it means to have the data in the cloud. There's discussions of services that ESDIS makes available for earth science data, and metadata. Why do you need it? Why should you have to spend your time, creating good metadata? And new to this version 2.0 is discussion about airborne data. So historically, we have not given airborne data as much love as we should have probably. The satellite data tends to get a lot of attention because there's a lot of it. But the airborne community said, hey, what about us? They don't use NetCDF format typically, so there's a discussion about the iCart format in this document this time, which is widely used for airborne field campaign data. These tend to be smaller data sets, and so it talks a little bit about why this file format is appropriate for airborne data. There's also a discussion about dimensions and coordinates, which includes specific examples and addresses specifically things like flight trajectories, flight paths that have been overlooked in the past and were not included in the last version. So if you are somebody that works with airborne data, this may be good news to you. As I said, there's a lot of discussion about optimizing data for the cloud, some cloud optimized formats, and then also how to optimize NetCDF4 and HDF5 data for storage in the cloud. And then finally, there's a lot of discussion about services available and what the relationship between metadata requirements and accessibility of those services, the usability of your data with some of the ESDIS services depends a lot on what kind of metadata you include and what kinds of standards you observe. And so there's discussion of that in this document as well. If that is too much for you to read, there is a cheat sheet as well. And that cheat sheet gives you a really concise overview of the stages of the product development lifecycle, from design all the way down to delivery of the data for publication at a DAC. And so this, we've provided links in the notes to this, these documents. So if you want to access that, you can. And this is a pretty concise and yet comprehensive cheat sheet that you can use if you're developing data products. Finally, I wanted to mention something that's a little bit tangential to ESCO, but relevant. The Data Product Developers Guide is being incorporated into the satellite mission lifecycle process. And one of the goals, as I think Steve mentioned at ESDIS right now, is making sure that the data that we get in from data producers is usable, interoperable with our services, and that there's not, sort of this after the fact. One of the things that often will happen when you're publishing data is that the data get delivered to you after they're all processed, the product's been designed and the data have been processed, and they send it off to a DAC. And the DAC is like, man, there's a whole bunch of things we'd like to change about this data. And that's a lot of work for data producers. So a big goal at ESDIS right now is to engage as early as we possibly can with data producers. And so we have a workflow management system that tracks the mission lifecycle process. And during the new mission onboarding, we have a task to get the Data Product Developers Guide into the hands of data producers and to work with them before they're even starting to collect data in order to ensure that the data they're producing is robust and usable. So this is a pretty big deal in the ESDIS world, this Data Product Developers Guide. It really is going to be the guiding document for data producers. There's another document that has been recently reviewed. It's a new version, I think, of an existing document, the Dataset Interoperability Recommendations document. This one, much like the DPDG, provides guidance on making good data. This is more fine-grained than the DPDG. The DPDG is a kind of high-level overview of recommendations. This one addresses specific interoperability issues that have been identified in the community and are known problems for interoperability. So some examples include the use of the missing value attribute, which is something that in NetCDF gets overused a lot. And so they talk about, not overusing it. So it sometimes is used, for example, to provide different codes, right? So people will say, values between X and Y are mean something, mean ocean, and values between C and D mean something else, land and forest or something like that. They recommend avoiding that kind of use because it really does cause interoperability problems. These are issues that have been identified, specifically in the community, and they have addressed many of those interoperability issues in this document. RINEX is a receiver independent exchange format. This is a data format for raw satellite navigation system data, and it is capable of integrating multiple types of receiver data from multiple types of receiver equipment and satellite constellations to combine those consistently in processing software. It ingests orbit information from disparate receiver types and ancillary meteorological instruments, and is a current standard for our crustal dynamics data and information system DAC at NASA. So if you are interested in formats for raw satellite data, this is a good format to look into. The ESDIS data use guidance webpage has been updated this year. It's now the ESDIS data use and citation guidance page. So we've added citation information to our data use guidance, and this is all arising from the new open science, the push for open science and efforts to ensure that the data producers, the original data producers, are getting cited properly and getting credit for the work they've done in journal articles, or where people are using data to do secondary data products, to derive additional data products. We want to make sure that those original data producers are getting cited properly. And so there's guidance now in this on this website for how to cite data products properly. The WIGOS measurement unit notation. This is a move to standardize the way we refer. This is a notation standard rather than a command to use certain units. The standard here is one that comes from the WMO group. They developed a notation standard for measurement units that is readable, right? There have been many issues with multiple ways of saying the same, of notating the same measurement unit, and that has caused interoperability challenges, and this is an attempt to address that challenge. So the WMO Integrated Global Observing System is a list of measurement unit codes or measurement unit notations. It offers notations for a comprehensive set of units that are commonly used to measure Earth science variables. It provides definitions for units derived and including derived units and non-SI units, but where applicable, it includes the SI base unit equivalents so that there is a mapping between these measurement units and SI units in notation. And the notation avoids special characters that are known to create machine readability problems. The measurement unit notation is, we think, going to help us standardize what is being put into data files and also what's going into our metadata files. And we hope that this is going to really help with interoperability issues. WIGOS uses a subset of ASCII characters that are readable very broadly. So it avoids things like Greek characters, like the mu character for micro things, right? And I just wanted to give you this example here. These are all ways of writing micrograms per cubic meter, right? There's many possible notations for that, but they're all specifying microgram per cubic meter. And so the WIGOS notation converges on a single option, and they use the U instead of the Greek mu. We discovered, Steve and I, when we were doing this, trying to share this review with the community, that it depended whether the way this mu character gets interpreted depends on the platform that you were on when you inserted it into a document. It depends on the platform you're on when you're trying to open the document. It depends on the software that you were using to write a document, and it gets converted, sometimes as complete garbage, sometimes as an M. We've seen the mu get translated into an M, which obviously you don't want if you're talking about measurement units. So this is why WeGos has, tried to converge on a single notation that any, or at least most systems can probably read and that will not be mistranslated.
I thought I'll just add a bit to that micro saga, because that created a problem for us when we were reviewing the documents, because different members of the team were seeing different things on different computers from the same document. And what we discovered is, there are several different ways of encoding the micro character. So there are actually two different Unicode characters that can be used to represent it. One is the Greek small letter mu, which is the preferred. There's a legacy micro character, which was used in older character sets before 64-bit character sets. That's sort of deprecated, but still around, and you can still create it. And if you're in Microsoft Office, you can put in a micro sign using Microsoft symbol font. But what that actually puts into the document is the lowercase letter m with a style around it, a symbol style tag around it, all of which look the same, but they're actually, technically different things. And if you do a mathematical comparison, this micro does not equal that micro, does not equal that micro. And it absolutely caused confusion for us when we were reviewing some of these documents. So that's an example of what this standard is trying to address. Sorry to interrupt, Beth.
Yeah, no, thanks for sure. Thanks for that example. Yeah, it gave us no end of trouble. It really took us a very long time to get the document that we were trying to review into the review. There's a software system we use to conduct the reviews, and it took a long time to go through and fix all of the translation errors that we ran into.
We had multiple different types of mu in the same document.
Yeah, exactly. So okay, so the WeGos measurement units are maintained. This is I think, one of the great things that we like about this. They're maintained by a team, a WMO team of experts on metadata. And that includes a bunch of metadata people as well as scientists who maintain this code list. And they have a well-established governance process. And that process is managed by a WMO standing committee on information management and technology. So it's a really well-defined process and a well-managed system of maintenance for this code list. Every unit in the list is properly and clearly defined with inputs from scientists and metadata specialists alike. And then the notation for each unit in the WeGos code is included with every definition. So I've put an example up here at the top of what a WeGos entry looks like. So microgram per kilogram. It tells you what the official or the approved notation is. It gives you a description or a definition, and it also gives you the SI equivalent of that. And so, we've decided to adopt this standard for ESDIS data as well. All right, the ATBD template there, that is the algorithm theoretical basis document. Template data products that get archived in NASA ESDIS archives are typically expected to include an ATBD, and the impact team down at Marshall developed a template that underwent a review in the ESCO process this year. And that template provides all of the sections that should be included in an ATBD and provide some guidance on how to fill in those sections. So the goal here is to make sure that the ATBDs that accompany NASA Earth Science data products are all consistent and include the information that should be in there and in the same order. And it just makes for a better user experience when data users can look at documentation accompanying data and sort of know what to expect and get what they're expecting every time. And so this template was reviewed under the ESCO process and ultimately was handed over to the Mission Lifecycle Process Working Group, which has taken it under its wing and is making some final edits to the document to address feedback that came from the community during the ESCO review. But that document will then be made available to data producers early in the mission lifecycle process so that they can develop an ATBD that is consistent and conforms with requirements at ESDIS. The UMM VAR, this is one that was near and dear to my heart. And full disclosure, I was involved in developing the schema, so that's probably why it's near and dear to my heart. But this is the unified metadata model for variables, and it's a schema for annotating, defining variables. If you're familiar with NASA data, you know that most of the data comes packaged up in what they call a collection, which includes multiple data variables. And the collection gets metadata that goes into the common metadata repository. But the variables, until fairly recently, did not. There's been a UMM var around for a while. It's a little bit underutilized. And so we undertook an effort to update the schema to address some specific variable-focused use cases. And to get these use cases, we talked to scientists and said, what are you doing with data? What are your pain points? And we ended up documenting 5 use cases that we focused on. Searching for variables by measurement type, searching for variables from specific missions or campaigns, and searching for variables in specific collections, and searching for variables by instrument. And then the last use case was subsetting files by variables, because another thing that happens, we have really large data products at NASA, and you don't necessarily want to download the entire product, every single variable in there. You may only want a couple of variables in that large collection. And so in order to be able to subset just the variables you want out of a collection, we need some variable level metadata that the subsetting systems can rely on to do that subsetting. So those were our 5 use cases. And ultimately, the UMM VAR looked at, how, thinking of this from a sort of graph-like view, the goal here is in variable level search, especially for users who aren't necessarily familiar with NASA Earth science data, that might not know what collection to look in. In many cases, they don't know what campaign to look in, what mission to look in for data. What they know, maybe, is that they want some black carbon data, and they want to know all the variables, all the data sets that we have that contain black carbon data. And so those might be in completely different collections. They might not be in the same collection. They might not even come from the same campaign. And so the schema was designed to facilitate that kind of search so that variables would get metadata records attached to them that described the data in terms of what got measured, what medium it got measured in, what what quantity of the thing measured was measured, right? And so the goal here is to allow data users to conduct a search where they can start from what they know and get to variables that way. So if you want to start from a collection or start from a mission or this is a model, if you want, you like the Mera-2 model and you want data from that, you can get to the variables from that. But you can also get there from something like black carbon or soil. If you're a person who studies soil and you want to know all the data, not just black carbon, but anything that was measured in soil, you should be able to get there through a search focused on variables. So this schema went through the ESCO review process and was accepted and approved by ESDIS. I will say it's on hold right now just because there's so much going on at NASA at the moment, and we don't really have the bandwidth to do implementation, the implementation that's needed to get this schema out into the world. So it's not available yet, but it has been completed and reviewed and approved. Okay, so let's see. The OFAIR, a practical guide for open, free, and fair NASA Earth science data products. This is an extremely comprehensive discussion of things that are near and dear to all of our hearts. FAIR principles, the challenges of making data fair, what NASA is doing to make its data more fair, resources related to making data fair, and what's the path forward for making data fair? What should we be doing to really realize the vision of fairness? This document is currently undergoing a second round of review, but should be ready to be released to the public soon. And just to give you some highlights of, and give you a sense for how comprehensive and how much work went into putting this together. It provides, for example, a mapping between NASA's Science Mission Directorate Policy 41A, which is the open science policy document at NASA. So it maps between that and FAIR principles. So to give us an idea of where NASA is in terms of making its data fair. It discusses different types of interoperability. So these are things that I think have all known, but typically we focus on syntactic interoperability, but there are other ways that data need to be interoperable. And so this document actually discusses some of those issues. And it links back. So just to link us back to the DPDG, there's sort of a theme here in this past year of standards that have been coming out because as ESDIS seeks to move its data, all of its data, into the cloud. And we are simultaneously trying to get rid of all of the little bespoke one-off tools and services out there that work maybe only on a single data product or work on maybe data from a single campaign or mission. There's this need, really burning need right now, I think, for us to figure out how we can create enterprise level tools and services that will operate on, a good percentage of the data in our Earth science archives. We want to make sure that the data that we are publishing and archiving is usable, including with sophisticated tools and services that might do subsetting or data transformation or eventually maybe analysis in the cloud. We want to have data and software services that are working on all of our data. And the only way we can get there is if we standardize, and follow the same guidance. If we all can start working towards getting data products that use the same speak the same language, use the same formats, and what have you. So that is the OFAIR guidance document. And then I think this is our last one. There are guidelines coming out for the citation of airborne facility instruments, again, driven by the open science world, you know, the push for more and more open science. There are instruments at NASA that are developed and maintained by NASA scientists that are used often by other scientists who want to do a field campaign, and they will ask to use these facility instruments, NASA facility instruments. So again, in an effort to make sure that the people involved in developing those instruments, who may not necessarily be involved in the campaign that's collecting data with those instruments, we want to make sure that those facility instrument developers and scientists get the credit that they deserve. So some guidelines for that, for citing those facility instruments, should be coming out soon at ESCO. Okay, so that was it for standards developed over the past year. Steve, you're
Beth,
coming
do
off
we-
mute. Did you want to jump in?
Yeah, I was going to say, do we just want to pause there and just see if there are any questions on
Yes.
that part of the session before we go into the data processing levels?
Yes, pausing. Any questions or comments, please? We would love to hear them. Concerns or anything else?
So I think most of the things that Beth referred to, most of those have been finished, and so they get published to the NASA Earth Data website, so earthdata.nasa.gov. I added some links in the notes to this meeting, so you should find some links there. A couple of those things are kind of in, they've only just recently been approved or in the final stages, so they may not be available just yet, but should be there within the next few weeks. So I think the Affair Guide is in the sort of final stages of approval. So there is a draft available. I did link to that, but the final version that should be available probably by the end of next month.
Can you guys still see my screen, or has it turned into a blurry mess?
No, that's good. We see it.
Great. Okay, so here is where the session was. If we had been in person, we were going to get really lively right now. I'm not sure if we're in a position to be lively today, but we'll try. So the data processing levels, most of you are probably familiar with these, but NASA has a
Oh, wait, we did have one question before we jump into the next. Is that?
Sorry, go for it.
No, it's okay.
Yeah, hi. Hey, Beth, this is Brianna Pagan. So yeah, first, thanks everyone. This is, I know, really tedious, hard work. And it looks like a lot of stuff was done the past year. I've always wondered on, especially for interoperability, like what's the enforcement mechanism here in terms of,
Yeah.
it's like all of these best practices, but we still then
OMG,
let
yes.
people publish data that doesn't meet other standards, right? Like, are we in, I know there's checkers for like CF compliance, right? But then there are still ways of people publishing their data. So where can that enforcement mechanism happen? Because that would ensure interoperability and a lot happier
Yeah.
people everywhere.
Yeah, for sure. Thank you. I'm glad you said that. Why don't we hold off on data processing levels, because that was going to be the next part of the session, was to talk about, whether Steve and I are here representing ESCO. So I also work at a DAC though. And Steve has other hats that he wears at ESDIS as well. And so, I am also really interested in this question, Brianna. What happens often is, we go through the review process. It's often the very same people that we already know and love, and are always involved in sort of this standardization effort. And then a standard might get adopted, and we put it on the website, and there it is for everybody to behold. But I'm with you. I don't know how we enforce it. We've got always there are naysayers, right? Not, I mean, no matter what what we're putting out there in an ESCO review, there's always a few, a one or a few or whatever people that hate it because they're doing something else and they don't want to change. And I totally sympathize with that. Um, but even just with the communication, like I'm not convinced that we're doing enough there. And so I did want to see if we could, even in this um, weird hybrid situation that is so awkward, uh, if we could have a discussion around what maybe what ESCO could do, or maybe what DAX could do. Is there something that would help people? And Brianna, I'd love to hear from somebody like you because you're developing stuff, you're working with data, developing tools in some cases, and there are these different groups of people that need to know about new standards.
Yeah, and I'm just gonna add, like, I'm no longer at a DAC, so I also feel a little bit more freedom to
Yeah, I
speak
know, I
here
love
now.
that.
And I just don't think like DACs are also incentivized to enforce, right? I mean, if you
Hmm.
get given a data set and said, well, we're not going to host that, then people can shop around and go to somebody that will. So I think there's,
Yeah,
some internal reason why a DAC wouldn't enforce things. But then we're
yeah.
all in a catch-22 of also um, wanting to have convergence of tools. And then we can't do that because the quote unquote quirky data. And so, unless people stop producing quirky data, like we can't converge tools, you're going to keep having people build custom things for their users. So,
Hmm.
yeah, I've always wondered like why can't ESDIS be that enforcer
Hmm.
of like we will not host data at NASA unless it's
Yeah.
compliant with these standards.
Yeah, I know. I have had that question on in my mind on occasion too. I mean, there are lots of reasons. One is that we don't want data producers to go complain to headquarters about us. Um, possibly, right? But let me take off my ESCO hat for a second and put on my DAC hat and say I have been involved over the last year, a little less than a year, in a working group, this mission lifecycle process working group. And one of the things that working group is trying to do is and there's some other efforts too. I mean, there are all these efforts and they're all linked, and it's hard to talk about everything that's going on. There is a lot going on to try to get to a place where it's not so much of an enforcement issue as it is that there's this early collaboration with data producers that allows us at the DAX who might have some expertise in what the metadata ought to look like and how the dimensions ought to be represented in the netcdf files and that sort of thing. And so I think that, instead of enforcement, what we're going for is this more collaborative approach. So the mission lifecycle process in combination with some other things, but when a mission gets funded, and I think this will hold for smaller campaigns as well. Sometimes they don't have to go through all the hoops that these big satellite missions have to go through, but when a mission gets funded right out of the gate, we want that science team assigned to a DAC, and we want the DACs to start working with the science team well before they've collected any data. We want to have the DACs providing them with whatever guidance documents are available that will help them design their products. And we want them to share that design with us before they start building out their processing software so that it's not too late, right? We want to start getting involved before it's too late to change the data. It is a big ask for a DAC to receive a big bunch of data to be published and go, oh, we're not going to publish this data, right? You need to go back and redo all this data. That's a heavy lift for many data producers. And as budgets get tighter and tighter, it's going to be possibly even less feasible to ask them to do that. And so I kind of feel like our best chance at addressing this is to try to get involved really early. I will also mention Earth Data Pub is a application that was developed. It's a cross-stack effort with in ESDIS. Many DAC staff participated in the development and the design of this. It's a tool for data producers to submit a request to a DAC to publish their data. And right away, we ask, send us some sample data, send us some sample metadata, again, in an effort to try to catch early if there are any problems that we can maybe work with them before they send us all of their data to publish. We can start tweaking the metadata or something early on in the process. So, that's one way of dealing, I think. Whoops, not what I wanted to do, of trying to address the problem. But even around the DACs, I'm not sure that the standards are always known. Which standards, Steve mentioned at the beginning of this session how many, right, which standard should I use? There are so many. The great thing about it is that there are so many. So anyway, let me pause there, and Brianna, jump back in if you've got any thoughts about anything I just said, and others, we'd love to hear your thoughts about this.
Let me just chip in as well, because I think one of the things I think Brianna mentioned was data checkers, and that's one of the things that is starting to look a bit harder at for all of the recommendations. So I think that's one way of helping is some sort of automated checking. So I think for the data product development guide, the dataset interoperability recommendations, and the OFAIR guide, we've also started looking at how we would implement checkers for some of those recommendations there. Not all of those recommendations can easily lend themselves to some sort of automated checker, but I think where they can, we're looking to put some resources into developing checkers.
Yeah, thanks. I'm going to respond. I'm going to pass it off. There's another question in the room here. But yeah, I know for EDPub, I think that was one of the requirement requests, at least coming from Genesis, was like implementing some sort of CF checker, because that is, how that DAC onboards data. But I just wanted to say, I regret also using the term enforcement. Like if there's some way to show people how much better it can be if they're just collaboratively, it is also cost savings. I know it might seem like a big lift for the data producers, but
Yeah,
the DACs serve as a consulting entity of like, if you do this, then all of these people will be able to access your data like this.
yes.
You're going to save us engineering and the rest of the world who are customizing workflows to make data work. So like, I do think there's a efficiency part of that, but there's another question here, so I'm going to pass it.
Okay, great. Thanks, Brianna.
I actually think it was sort of answered, because I was going to ask about tooling and make a comment on, like, with enforcement, it seems like having like a nice name or a badge or something, like making it visible when you're in compliance, like just like a little bit of shame goes a long way for enforcement, I think, a lot of times.
Yeah.
So I guess it was more of a comment, and you addressed sort of the tooling, because I was wondering if there was something to like really understand like which data sets and stuff are in compliance with those. Is there, like, across the standards you've outlined, like, is there kind of a visible, like, to that end, is there a visible way to see, like a very visible way to see this across decks, like what's in compliance and what's not, and like, so there's not surprises on the user side, or is that still kind of up to the user to investigate?
Yeah, so that's a really complex question. We do.
I think the short answer is no, there isn't an easy way to see it. I mean, I think it's all been on the honor system,
Mm.
ESDIS has produced recommendations and standards, and the assumption is that people will follow those things. But I think you know that we it hasn't been enforced. So I think things
Right.
like having data checkers will and and as you say, having some way of flagging the things which have passed those tests would be a good way of enforcing those standards.
One
Yeah,
thing that
'cause
can happen too is that data producers will come to us, and especially if it's a small, not it's like a Roses funded project or something. They don't have a lot of money to do this, and they come to us and the data's already done and they want to publish it, and it's not in the it might be in NetCDF, but it's not, maybe it's not NetCDF 4, or maybe it's not CF compliant in some ways, and it's a really hard thing to know what to do at that point, and they're kind of like, "No, we can't, we don't have the money," especially with these Roses funded projects, if they've moved on in many cases to the next project, right? And they can't really circle back and redo the data, and so in those cases, we run the compliance checker and we go, "Oh, it's not compliant. What are we gonna do?" And then we publish it anyway, right? So that can happen. Um, and because they're required in many of the NASA funded projects, they're now required to publish their data with a DAC. And so it's hard for the DAC to say to them, look, we're going to make you fail this requirement by refusing to publish your data. We can't really do that. And so we publish it, and so it's out there. But I think a consequence of having non-compliant data in the sort of shaming category, I guess, not shaming, but it is a shame, is that data won't be usable with many tools and services. And that's a issue that's been raised. Another hat I wear is on the user needs Tiger team, and this has come up. Well, we have this tool that we love, but the data we want to work with doesn't work in that tool. Or we have this data that we love or that we'd like to love, but it doesn't work with any tools, right? And so that is going to become a bigger and bigger problem as there's less and less funding for DACs have in the past written bespoke software to work
right.
with just one particular data product. We're not going to be allowed to do that anymore. And so, if people bring in data that really is not interoperable with any tools or any other data, that data is not likely to get used. And
Right.
that's a metric that they're evaluated on. So,
Right. It sounds like what you're saying is that there's tools for the checking of compliance on certain things, but not necessarily for reprocessing or trying to meet.
right,
Okay.
right.
And
Yeah.
then I had a follow-on question, sort of from like a CIOS international perspective. I was curious to know if there was sort of an assessment of like across other agencies and whatnot, how some of this compares, or like I noticed there's like some adoption of different standards and whatnot. Is that in line with kind of other data producers around the world, or in, even the United States? And
Yeah.
also, if from a kind of a CIOS perspective, is like any of this, maybe trickling up to like CIOS, or kind of, I guess advising other people to kind of unify, speaking to interoperability.
Yes, that's a really great question. So let me talk about the WIGOS measurement units. That's obviously an international, that's a WMO standard that we've just recently, that was pushed by the airborne community largely because they work a lot with the WMO group. And this came up, Steve, help me out here. How did this fall out? Unidata UD units are, I meant to mention this actually when I was talking about WIGOS. So currently NetCDF, I think what it says is something like any unit recognized, or sorry, any string recognizable by UD units can be can be used as the units in a netcdf file. And so this came up in the process of reviewing that particular proposal for a standard. And there were some objections, but we tried to reach out to Unidata, to somebody at Unidata, to see if we could check the compatibility of WeGos with UD units. And also to say what we're asking of UD units is not that they make a huge change, but rather that our data producers, if those WeGos unit notations are strings that can be recognized by UD units, so much the better, right? We will ask our data producers to confine themselves to those strings and not the other possible strings, right? That involve slashes and muse and different things that we don't want in our data files. Steve, can you jump in and maybe elaborate on this issue? Because we found out later that there is actually a desire, at least, I don't know if there's an actual effort underway, but a desire at Unidata within the UD units community to do
So I think,
something.
right. So I think this all raised an issue which I'm not sure people have necessarily sort of been aware of. We looked into into UD units, and what most projects are doing is just say, well, as long as UD units accepts it, then it's okay. What UD units does, it accepts multiple different representations, notations for the same unit of measure. So UD units isn't trying to validate the particular notation, it's trying to just make sure that it's a recognized notation for a particular unit. So I looked into the code list for UD units, and it does have multiple notations acceptable for any particular unit of measurement. So I think one of our next steps, what we do want to do is to do a more thorough checking of the WIGOS units of measure to one, to make sure that all of the WIGOS units are accepted by UD units. That should be sort of one of our next steps. One of the complications I found out there as a Unidata, and this was last year I was looking into this, but the guy who'd been responsible for UD units had recently retired, and nobody else had kind of been put in his place, but he was the guy who had the whole history of where everything came from. So it got a bit more complicated. So but UD units isn't trying to control a particular set of notations. It wants to recognize all the different notations for a particular unit of measure. Whereas we want to, try and standardize on a particular notation.
Mm-hmm.
We also want to make sure all of those notations that we want to standardize on are accepted by UD units. So that's a chunk of work that we have yet to do.
Yeah, and that kind of circles back to the question of compliance checkers and that sort of thing, right? It would pass as long as the strings are recognizable by UD units, then a compliance checker run on a netcdf file that used WeGos unit notations would pass, but also would one that wasn't using WeGos would pass, right? If it was using some other string recognizable by UD units. And so we want to enforce the WeGos notation. We want our airborne data to be.
So I think we could, I'm kind of going off track here. I think we could do that because you can customize UD units. So
yeah. Okay.
There's a file that contains all of the notations that UD units uses. It's intended that you could add your own, add additional ones in there. But I think we could also take ones out of there if we wanted to, and create an addition of UD units that only validated the WIGOS units of measure.
All right. So any other comments, questions, ideas? Let me just throw this at you guys for a second. Like when ESCO conducts a review, one of the things we do is ask the proposer to give us a list of people that they want to have involved in the review, and they typically do. Typically, those aren't necessarily going to be people that are going to have a lot of objections, because often they give us the list of people that were helping them, come up with the standard or whatever it was. But we do tend to get, often we'll send out a review notice to a lot of people and not get the majority of them reviewing. So there's that initial communication issue, like, would people be interested in trying, like, for those of you who aren't regular NASA people, are you interested? Would you be interested, willing to get involved in ESCO reviews, or would you rather just wait and hear about it after the fact?
Yeah. Hey, Beth, it's Brianna again. I mean, I think especially now as someone who's not in NASA ecosystem, it used to be easier, right? Like I had JAMA access, like it sounds
Yeah.
minor, but now I get those emails and it's such a hurdle because it's like in my personal email. And, like, is there any way to like post them openly somewhere so that way
Oh my
anyone who wants
gosh.
to contribute could? Anyway,
Yes.
it sounds minor, but like really like having someone log into like a system and knowing their emails and stuff, I think is a blocker. But if there's a GitHub issue or something equivalent,
Yeah.
posted publicly that I don't have to log into something just to see it and see if I can even give feedback. Because I think that's also sometimes you get these requests and you don't even know what you're committing to review because you actually can't
Right.
see the document until you accept the request. And so, yeah,
I want to take that as something we have heard this before, and Steve is the man on this. Maybe I'll just let you. I love Google Docs. I would love to just put the thing in Google Docs and let people comment away on it in there. We do have an alternative method where we let people download the document and comment there and send us back their comments. But it's hard to collate all of the comments if they're coming in separate documents. And so I think that's one reason we like JAMA. But Steve, do you want to add anything to
Yeah, so
that?
well, let me just chip in there. So you don't have to have an SID to participate in the reviews. One of the things we use JAMA rather than some of the other tools is that it uses the Earth data login credentials, which can be issued to somebody who doesn't have an SID. So Brianna, you should still be able to participate in reviews, and we could give you access to JAMA. But it's right. The other part is knowing which reviews are going on. And we do.
sorry that there's one other question in the room, but I was going to say if I wasn't in NASA, I wouldn't have known about the JAMA review process though. Also,
Mhm.
like it's only because I was within that and
Right.
knew the system, and now I'm out of it and I know of it. But before that, I would have never heard. But there's another question in the audience.
Yeah, and while we're thinking about this, I just would love for people to think a little bit about how we could expand out to a broader audience, communicate these things, to a wider. ESIP might be the way to go, actually, now that I'm saying it out loud. But go ahead. Sorry, I didn't mean to thwart the other question.
This is actually in response to your question. This is Max Jones from Development Seed. I previously engaged with the ZAR standards review and really appreciated being involved in that experience and would be glad to do so instead. And I am so impressed by all the work you've been doing this last year. I didn't know about it until now, and I think that's because I switched positions. And so any emails to my old
Okay.
email address, I probably haven't seen. I'd be glad to help with posting new reviews on different Slacks and discourses like through the Pangeo and Cloud Native Geospatial communities, if that's helpful. I think those open forums are a great way to get out news.
That would be awesome. I really do think it would help us to hear from this, and especially from the developer community. And, we need a lot of different perspectives on this, data producers, developers, DAC staff. So yeah, thank you for that. Did you put your name and email in our sign up or our meeting notes somewhere so we can reach you?
Yeah, I'll do that. Thanks, Beth.
That would be great. Thank you so much. Yeah, and I mean, maybe we should blast it out to different mailing lists when we're doing reviews. And same with after the fact, once the standard has been recommended or not recommended, after the review, the ESCO team typically does a write-up, strengths, weaknesses, strengths, weaknesses, something, something.
Applicability and limitations.
Yeah, applicability and limitations, yes, and then write a recommendation that we send up to ESDIS. And then if ESDIS, if we recommend that it be adopted, and ESDIS the staff up there will also look at it and make a decision about whether they agree with us or not. And once it's adopted, we also need to get the word out to people that, here's the new standard. Try to start using it if you can. And if you're writing software, then try to make sure that your software can read WeGos notation, for example, right? So yeah, thank you for that. I appreciate that that offer very much. Anything else on this topic? I think collaboration really is our secret sauce in this stuff. So all right, I'm going to move on to data processing levels. I think, here we go. So this is an interesting problem that we undertook to solve. And just to remind people, or if you're hearing about this for the first time, NASA has these data processing levels. There's a set, there's an official set of definitions. Level 0, 1A, 1B, 2, 3, and 4 that are sort of the standard ones, the approved standard ones. But in reality, in our common metadata repository, we've had this proliferation of, other things, right? We've got 1 level 2 in the official standard, but we've got in our the stuff people put into their metadata includes 2A, 2B, 2G, 2P. Some of these don't have any definitions at all. Some of them have unclear definitions. Steve and I sat down and took a look at this and thought about what should be done to solve this problem. And we had this whole proposal. We were going to form a working group and we were going to try to rewrite definitions. It ended up that we didn't form a working group. All hell is broken loose at NASA. So we're just, we did this kind of on our own. We reached out to some people that had some expertise in this, but we looked at the definitions ourselves, at these definitions, and we reached out. Even some experts were unclear. One of the things we decided that was driving this proliferation of standards is that the definitions themselves aren't entirely clear. And so you're not sure. And I think if you're the person, I think somebody in the room said they were here as a CIOS person. You guys, I know, have been talking about this, and it's just unclear, right? What is meant by a derived geophysical variable? What does it mean to be processed to sensor units versus being a derived geophysical unit, right? What do we mean by this? There's some question about, now that we've got gridded data, that's being observational data being supplemented by model outputs. What do we need to do with that? And so Steve and I started rewriting the processing levels in an effort to, first of all, return to the original ones and just get rid of all these other ones that are really cluttering up for now, so that we could have a clear set of basic definitions about processing levels. And so I have this document. I have linked to it on the notes page. I've linked to it in the slides. I have made it shareable with anybody who has the link. If you can't access it, feel free to just request. I will give you access. Um, we're a little bit stuck because even experts were kind of like this definition, like for level 0, it says data products are reconstructed. Level 0 data products are reconstructed, unprocessed instrument payload data at full resolution. And so we wanted to know what that meant. What does it mean to be reconstructed and unprocessed? Because reconstruction sounds like a process to me, right? And so I was a little bit confused, and nobody seemed to have a good answer. And so we, started rewriting these, and we just have what you see here on this page is where we are. We poked around a little bit, and it seems like actually reconstruction is the process of turning analog data into digitized data. And so that's the reconstruction thing. But there's no other processing happening. So we rewrote this definition. It might be completely wrong. This is so far from my area of expertise that, I don't want to be, I would very much like to have as many eyes on this as we can possibly get. Steve probably has way more expertise than I have zero, so Steve has more for sure. But this is what we've come up with, and we wanted to just, talk about a couple of things with you guys. First of all, we'd like to get feedback and input, and some answers to questions. So level 1A, we rewrote a little bit. The stuff in red is sort of what we added here. That level 0, we would love this to be recursive, a recursive set of definitions, so that we've got level 0 data, which is this, and then level 1A is level 0 data that has this additional thing happening to it. Level 1B is level 1A that has this additional thing, right? So that we can define each increasing processing level in terms of the previous level, so that we know exactly what we've got by the time we get to level 4. So this is what we've done. We've added, I had to go poke around because, again, I'm not an expert on this at all. And I was like, oh, proxy signals, what are those? So, we couldn't figure out, for example, the difference between level B and level 2 data. I mean, not that we didn't think that there was I couldn't anyway. It wasn't clear to me what the difference was and what it meant to be processed to sensor units. So we have been trying to clean up these definitions. That's the first thing we wanted to put out there for your review, for your help, and any input you'd be willing to provide to this. The second thing is that we recognize that the proliferation of processing levels has happened because people go, these processing levels don't really describe my data. They're not enough. And I need these additional, all these additional level 2 things, especially. But we wanted to consider the possibility that those additional properties are either the result of a lack of clarity in the current definitions, or are better treated as metadata somewhere. And maybe we should think about whether or not any of the UMM metadata schemas need to be updated to accommodate some of the additional stuff that and it's hard to know because the 2G and 2P.
Beth, can I?
Yeah.
Sorry, can you make the document slightly larger so that folks
Oh,
here can see it?
yes, of course. Sorry.
No, it's all right. Thank you. Good. Perfect.
Is that good?
Yeah.
Yeah. Yeah, so we've got 2G and 2P. We don't know. Somebody stuck them in there into our GCMD keywords, and nobody really knows what they mean, right? But we have some data products out there that have level 2G and 2P designations, and we've got 2A and 2B that have some definitions, but what, right? What are what is this? Having been processed to sensor units, is that not the same thing as being a derived variable? I'm not sure, because when I looked into what that means, the definition seemed to be that processing to sensor units means you take something, whatever the observable measurement that the satellite is measuring, like radiance, emitted radiance or reflected radiance or something, it's coming in some unit that isn't necessarily temperature data, as an example, right? If you're measuring radiance, the units in that raw data are not what you're ultimately going to put the data out, what the same as the units you're going to use Kelvin or something, right, later on. And that's that processing. But is that not the same as making a derived variable? I don't know. And
Yeah.
we need help. So
Hey, Beth. I mean, I
yeah.
would definitely defer to CEOs in the room here.
Mhm.
But I think it was last or 2 years ago, ESIP, where we were watching OGC present that they had made an ARD SWIG based off of the CEOs definitions. I don't know where that stands, but also wanted to throw out that OGC's next meeting is in Boulder in October. So like might be a good
Oh,
chance for you to
yeah.
go to something. But
So I think
Yes.
the specific OGC ARD thing has been put on hold.
Mm.
The ARD stuff definitely continues under CIOS, with at least for the different products and whatnot. But I also don't know the applicability to larger range of data. I mean, right now there's SAR, aquatic reflectance, land reflectance, several others that are in process, but yeah, it, yeah, yeah. Yeah, she was commenting that we don't want a specific NASA flavor of the definitions, and if they can be
Yeah,
uniform across would be good.
for
It's
sure.
definitely an
Yeah.
area that would be good to look at.
Yeah, and we are aware of the work that CIOS has been doing. Being NASA, we may have said, I don't, that's too much for us to, we like our basic processing levels here.
So
Yeah,
I think
and
that
it gets even
there's
more confusing across, like the other agencies have their own processing level. It's just but
Yeah, I mean, this set of definitions has been around since 1908. No, it's 79. It's really old. Um, so, but that both argues for and against changing them, I think, in some people's
so
minds. So,
I think that's one of the problems. They're old, and they assume a certain product life cycle.
Mm.
And I think once upon a time, everything went through things in a certain sequence, and so it was very simple to have one, two, three, four, and everything went through in that order. But product life cycles are a little different these days. There are a few deviations, and that's why we're getting all these letters being tagged on, because it's not
Right.
quite the old level 2. There's a little bit of a difference there. So somebody wants to put an extra letter on. And then we've also got the non-remote sensing products, which follow a different life cycle. So how do we tie those into a
Right.
processing level? And
Right.
then
The
I
in
have,
situ people are like, these don't speak to us at all. Right.
right. And then I have a complication with
None of
compound
the above.
variables, because
Yeah.
that's what we've really got here is, a single number representing a number of different things. And it kind of works when all of those things always happen in the same order. So you process, you put things into a standard file format, then you change an instrument reading or a remote sensing reading into a geophysical variable, and that's your first step. And then you do the gridding as a separate step. If those things don't happen in that order, you're trying to muddle several different things into one number. I think that's what you were getting at with saying, should these be separate metadata elements? Is it gridded, not gridded?
Yes, exactly. Thank you, Steve. That is a question, right? What if instead of trying to build that into processing levels, would it make sense to have that added to, say, the UMM-var schema in the case of derived variables? Could that be an attribute on the data that goes into metadata? So that was one idea that Steve and I have been tossing around, although not, I admit, not very rigorously. We've been a little bit remiss in dealing with this, and we probably need to get back to it. So what's I'm curious to know what's the status of the efforts that CEOS was engaged in. We had gotten a proposal, or an email from Siri Joda and the Steve, who was the other guy who were interested in trying to work with us on this.
I don't know if I've been privy to all that. Was this part of WIGIS, or was this under one of the working groups, or
Oh, I don't know. Steve, do you know?
Yeah, it was one of the working groups. I'd have to
Okay.
look that up. I don't remember offhand.
because I feel like most of this would fall pretty firmly under WIGIS, and it may be one of their subgroups
Okay.
trying
Yeah.
to tackle that. And I think most of what you're going into would be of quite a lot of interest within that group.
Yeah.
Okay.
So yeah.
Yeah, they had a proposal, is maybe an early draft of a proposal that would separate out issues like geospatial and temporal processing from data variable, derived variables, and sort of the actual data and what's being measured, and what processing that has undergone. So I think the idea was that, there are different types of processing happening, and some of it is like the gridding or be gridded or non-gridded or swath or flight track or something, versus what's the data, what's happening, what processing is happening to the actual data itself. Who's deriving what from whom or something like that. And so that kind of, I think, seemed reasonable to us, but for some reason we didn't want to. I don't know, Steve. I can't remember now what kind of happened between them submitting that to us and now. But yeah, anyway, we'll not solve this. We only have 2 minutes left. But know that this is a thing happening, and we would love to collaborate again with as many people as possible. For now, if you want to just go into this Google Doc and write comments, I think I've given everybody access.
Definitely. I mean,
Anyone?
if you know people we should be talking to about this, I think that's been part of our problem, is finding the
Yeah.
right people to.
Right. Who knows? Yes. Who knows how to answer these questions? That would be really helpful. So feel free to go in here, recommend people, recommend your ideas, put in your ideas or your comments about how you think this should be updated, or if you think we should just throw it all out, that's useful information as well. So that is it for
We have one
us.
more.
Oh, okay.
Yeah, well, I guess just a small comment about the levels. Like, it does seem like the descriptions of the levels one comment about how things used to be done and whatnot. You know, it does seem, are these stops on the way of the processing on the producer side, or are these handles that are really useful for the consumer side? And it's like maybe some
Right.
separation between those. And, you know, for instance, you know, ARD has a whole lot more than just a processing level to
Yeah.
not a ton more, but there's more to it than that a little bit. And you're trying to serve, I think, two purposes sometimes when you're entering at these levels, where it's like it's a checkpoint at the processing on the processing side, but it's also a handle for consumers to try to understand what they're grabbing. And certain
Yes.
consumers want to jump on the train at different points and than others, you know. So just a comment
Yeah.
there of trying to
No,
separate
good,
those two
good
concerns.
point. I mean, for sure, you know, whether a product is level 2 or level 3 can make a big difference for data users that only want to deal with gridded data. Or maybe only don't want to deal with gridded data. Maybe they only want level 2 data. That is, I think, a big search thing that has been captured in Earth data. That's something that people actually filter on a lot. But yeah, do they want to filter on, you know, do they care if it's level 2, 2G or 2P? I don't know. And yeah, anyway, that's a really good point. I think last year at our session, we had a speaker who was talking from the data producers side that they had, like, I don't know, dozens, it seemed like, of processing levels that they used internally as they were developing their data products, that seemed completely divorced from what a user might care about, but were really important to them as data producers. So maybe trying, you know, to make the distinction between those two types of people would be helpful in moving forward with this. Okay, so I think we're out of time, and I don't have anything more. Steve, any final words?
No, thank you, Beth. Thank you, everybody, for attending. We're always interested in hearing from anybody who's interested in getting involved in standards. So thank you to those people
Indeed,
who
we
spoke up.
are.
Yeah. You know, having members of the earth science community who you know, that we can call on and maybe sort of help give us advice is really useful, because otherwise it's the same people looking at it all of the time. And
Right.
you know, so having that broader community input is, I think, important.
It's really valuable. Yeah. Thank you so much for attending our session, everyone. And I hope you're all enjoying ESIP very much. And I'm jealous. I wish I were in Seattle with you.
Right. All right. Thanks, everybody.